Hello, I'm making this video mainly for the benefit of further maths stats students who are revising for the OCR maths stats exam of 2022, where there is definitely going to be a question on combination of random variables, which I'm assuming is normal distribution. It might not be, but just the example I'm going to do here is normal distribution. The question's a bit of an old one, which means that some of the mark allocation, particularly on the first one, would not be appropriate now, because this would be a 1-mark question because we're going to use a calculator for it. But there aren't enough recent questions to cover all the material that might come up. Nowhere near, really. So anyway, let's get on with the question. It's about a triathlon race where there's 3 different disciplines which are all normally distributed. Swimming, let's call this one swimming for S. Which is normally distributed with mean 11.07 and standard deviation 2.36 squared. We'll call C normally distributed 50, this for cycling, 57.33 with standard deviation 8.76 squared, and running normally distributed 24.23, standard deviation 3.75 squared. Okay, so the first bit is just about the swimming time, and as I say, this would in the syllabus that we do only be 1 mark if it had come up at all. So we have the probability that S lies between 10 and 13. S lies between 10 and 13. Doesn't matter if it's exclusive really, but I'll put it like that. And there we can just bring the calculator up to do this. It's a simple suited point. Just get the calculator to do it, and that's that. So it's the distribution number 7 that we want on the FX9911 class whiz. And we go for normal CD. The lower is 10. The upper is 13. The standard deviation is 2.36 and the mean is 11.07, and we simply just put that, and that's 0.04681. 4681. Okay, so that's the first bit done. Right, now this is the main bit, which might be the kind of thing we need to look at for, in terms of combining the random variables. Well, basically it says find the probability a chosen competitor running time exceeds the swimming time by more than 10 minutes. So let's call the running time R. Let's call D for difference, is the difference between their running time and their swimming time. Then we just use expectation algebra. ED will be equal to ER minus ES. So that's equal to the mean of those two, 24, the difference between the means of those two, which is 24 minus 11.07. And that comes to 13.16. But the var of D is equal to the, and remember variances, we're always adding variances. It's basically, it's var of D plus the var of S, because, well, we're always adding variances. We never take them away. I suppose we could regard it as an application of this. If we've got AX plus BY, the var of AX plus C is the variance of that is equal to A squared, the variance of X, plus B squared, the variance of Y, plus, oh well, not plus C because that gets dropped, because C is and in this instance what's happening is we could just regard B as equal to -1. So -1 squared is +1. So variances are always added. But remember, we're given the standard deviation here, so we're adding the variances, so that will be equal to 2.36 squared plus 3.75 squared. And that comes to 19.6321. So that's the variance. So we can say that the standard deviation D is normally distributed with mean 13.16 and standard deviation 19.6321, the square root of that. Sometimes write it like that to emphasize the fact that the standard deviation is the square root of the variance. So now it says that the time exceeds the swimming time by more than 10 minutes. So we want the probability that D is greater than 10. So again, we can go to the calculator. We don't have to do any Z distribution at this level now. We can just use the calculator for that. So menu 7, and it's normal CD. So in this case, we've got the lower is 10. That's still 10, just by coincidence. The upper, we just can choose an unlikely large number from this distribution now. The standard deviation is about 4, so 100 would certainly be good enough. Don't have to go over the top. I put 1,000 in there, but that's certainly good enough. Some large number. Standard deviation, and it will accept us putting the square root button in here, so it's 19.6321, sorry. And the mean is 13.16. And that comes to 0.7621. And then the next question, it says, for a randomly chosen competitor, find a probability that the swimming and running times combined exceed 2/3 of the cycling time. So what can we do here? I might just let X be the difference between the total. So X, with the distance between the total of the swimming and running time. So that's S plus R. Minus 2/3 of the cycling time. Okay, because so find the probability the swimming and running times combined exceed 2/3 of the cycling time, and then what we're going to do is find the probability that this is greater than 0, so that these two together exceed this. So what I'm going to do is define a distribution that represents that. So then what I can do is say, right, EX, expectation algebra again, is equal to ES plus ER minus 2/3 EC. So that equals to ES, which is 11.07, plus ER, which is equal to 24.23. Take away 2/3 times by the 57.33. Okay, and that comes to minus 2.92. Okay, so that's the mean of this distribution X. The variance, again using this rule, this kind of rule for combining variances, which is var of ax plus by plus c equals to a squared var x plus b squared var y, and the c bit disappears. And of course you can add that with a third distribution here. So the var of x equals to the var of s plus the var of r plus the var of r minus 2/3 squared times the var of c. So that's 2.36 squared plus 3.75 squared minus 2/3 squared times by var of c, which is 8.76 squared. And that comes to 53.7377. Okay, so we've now found the distribution, the normal distribution for x by combining them is normally distributed minus 2.92 with variance 53.7377. Write it like that. A bit awkward, but at least we're not going to mix up variance and standard deviation doing it that way. So then we can find the probability that x is greater than 0. So that equals to, that's equal to, so bringing up the calculator one more time, lower 0, because we want the probability x is greater than 0, upper some very unlikely large number on the right hand tail. The standard deviation here is the square root of 53, which you can type, it's actually written in there, but you can type that in, 53.7377. The mean is negative 2.92, and so we get the answer 0.3452. Okay, that's it. Better rush this video off as the exam's tomorrow. Good luck. Bye.